Hello friends, I welcome you in lecture number 11 on higher order partial differential equations. In this lecture, we are going to discuss one more question on the shortcut method for finding particular integral of non-homogeneous differential equation. In lecture number 10, we have discussed how to find out particular integral when right hand side function is either sin ax plus by or cosine of ax plus by, and we had discussed one example on this shortcut method when right hand side is either sine or cosine of ax plus by. So today also we are going to discuss one more problem of the non-homogeneous equation in which we have particular right hand side, that is sine of 2x plus y. As we know, first we have to solve the corresponding homogeneous differential equation. So first I am writing the corresponding homogeneous partial differential equation to the given equation. The corresponding homogeneous partial differential equation is, we can write it by considering right hand side equal to 0, 2d square minus 5d d dash plus 2d dash square z equal to 0. And we know that the general solution of this homogeneous PDE is complementary function of given non-homogeneous PDE. And for that, first we observe that here function of d and d dash is homogeneous in d and d dash. We can see that f d d dash is 2d square minus 5d d dash plus 2d dash square. And if f d d dash is homogeneous, we write down the corresponding auxiliary equation and we equate it, we find out the values of m. We replace d by m and d dash by 1 in f d d dash and equate to 0. So we will have 2 times m square, here I replace d by m, minus 5 times m into 1 plus 2 equal to 0. And now we find out values of m satisfying this equation. Here 5m can be written as minus 4m minus m plus 2 equal to 0. From these two terms we can take 2m common, and here we will have m minus 2 minus, here we take negative 1 common and we are left with m minus 2. Again we can take m minus 2 common, therefore m minus 2 times 2m minus 1 equal to 0, and this gives me two distinct values of m equal to 2 and m equal to 1 by 2. And we know that if we have this real and distinct roots, then corresponding to each value of m, the part of complementary function is written as arbitrary function of y plus mx. So we take m equal to 2 and m equal to 1 by 2. That will be the complementary function of given non-homogeneous equation. Complementary function is arbitrary function of y plus mx. First we consider m equal to 2, that is y plus 2x, and then we consider m equal to 1 by 2, that is y plus 1 by 2 times x. This we can rewrite in another form also. This I keep as it is, arbitrary function of y plus 2x, and this I can rewrite as, if I take 1 by 2 common, and this I can write as 2y plus x. So this is also function of 2y plus x. Here 1 by 2 is constant. So we can use another notation for this function of 2y plus x. Instead of phi 2, say we consider psi 2. Psi 2 is a function of 2y plus x. This is the complementary function of given non-homogeneous equation. Now we try to write down particular integral. So as we know, particular integral is 1 divided by function of d dash operated on the right hand side, which is 5 sine 2x plus y here. 5 sine 2x plus y. 5 is independent, that I can take outside, and let me write what is function capital F. It is 2d square minus 5d d dash plus 2d dash square. 2d square minus 5d d dash plus 2d dash square sine of 2x plus y. Now as we have discussed in lecture number 10, that whenever we have sine of ax plus by or cos of ax plus by, first we find out what is a and b. If we compare this 2x plus y with ax plus by, we see that a is 2 and b is 1, and we know that for this method we have to replace d square by negative of a square, d dash square by negative of b square, and d dash is to be replaced by minus a into b. So using this method, here I will replace d square by 2 into negative of a square. A is 2, so here I have minus of 2 square, that is minus 4. So d square is replaced by minus 4. Minus 5 times d dash. D into d dash is replaced by minus a into b. A is 2, b is 1, a into b is minus 2. So I replace d into d dash by minus 2. Similarly, d dash square is replaced by negative of b square, that is negative of square of 1, which is minus 1. So here I write minus 1 sine of 2x plus y. And now I have to check whether this is 0 or non-zero. If it is non-zero, then we will keep it as it is, otherwise we have to modify. So we can see this is going to be minus 8, minus 5 into minus 2, 10 and minus 2. So we can see this is 10 minus 10, that is 0. So this becomes 0 if we replace d square by minus a square, d dash square by minus b square, and d dash by minus ab. So as in the case of exponential function, whenever this f d dash becomes 0, then we have to differentiate f d dash with respect to d and multiply by x. So here I multiply by x and I differentiate this function with respect to d. So here I am writing 2 into derivative of d square is 2d. We will consider d dash as constant. We are differentiating this partially with respect to d. 2 as it is, partial derivative of d square with respect to d is 2d. Then minus 5 into d dash as it is, partial derivative of d is 1, and plus partial derivative of 2d dash square with respect to d, that is 0, because there is no d here, and while differentiating with respect to d, we will consider d dash as constant. So now this is, let me rewrite properly, this is 1 divided by 2 into 2d, that is 4d minus 5d dash. This I have to operate on sine of 2x plus y. Now here there is no d square, there is no d dash square, and there is no product of d and d dash. So whenever we have this type of situation, then we have to multiply numerator and denominator by some quantity such that we will obtain d dash square, d square, etc. So here I multiply numerator and denominator by 4d plus 5d dash. Here I have 4d minus 5d dash, so I am multiplying by 4d plus 5d dash, numerator and denominator both, and let's see what happens. Sine of 2x plus y. Now this is equal to 5x. We will keep this quantity as it is. First 4d plus 5d dash as it is, and this is the standard formula of a minus b into a plus b, that is 4d whole square, which is going to be 16d square minus b square. Instead of b we have 5d dash, so square of 5d dash is 25 times d dash square, and I have to write sine of 2x plus y. Now we can see we have obtained d square and d dash square. So again we will replace d square by minus 4 and d dash square by minus 1. So let me write d square equal to minus 4. This is as it is, 4d plus 5d dash as it is. D square is replaced by negative of a square, a is 2 and square of 2 is 4. Similarly, d dash square is replaced by negative of b square, b is 1, that is d dash square is equal to minus 1, and we keep this as it is, sine of 2x plus y. And now we can check again that whether denominator remains non-zero after replacing d square and d dash square by minus a square and minus b square. This becomes minus 64 and plus 25, and this is 4d plus 5d dash sine of 2x plus y. Now this is going to be the quantity in the denominator. Minus 64 plus 25 is minus 39, so I keep it outside, negative sign, minus 5x by 39. And now we have to operate 4d plus 5d dash on this function sine of 2x plus y, where d stands for partial derivative with respect to x and d dash stands for partial derivative with respect to y. That is 4 times del by del x of sine 2x plus y plus 5 times del by del y of sine 2x plus y. Now in the next step we write down the partial derivatives. So let me write this as it is, minus 5x by 39, and here 4 as it is. Partial derivative of sine function is cosine of 2x plus y, and into partial derivative of 2x plus y with respect to x, that is 2, that is by chain rule. Same thing here. First we differentiate sine function with respect to y, that is sine of 2x plus y, into partial derivative of 2x plus y with respect to y, which is 1. And now let me rearrange all these things. This is minus 5x by 39. This is going to be 8 times cosine of 2x plus y plus 5 times cosine of 2x plus y. And this turns out to be minus 5x over 39, 8 plus 5, that is 13 cosine of 2x plus y, and this 13 will get cancelled with this 39, and finally our particular integral is minus 5x by 3 cosine of 2x plus y. And then we have to write down the general solution. General solution is nothing but addition of complementary function and particular integral. So therefore the last step is we always write down general solution is y equal to complementary function was arbitrary function of y plus 2x plus arbitrary function of 2y plus x, and this particular integral is minus 5x by 3 cosine of 2x plus y, where this phi1 and psi2 are arbitrary functions. Let me check what is complementary function, whether I have written it correctly or not. Phi1 of y plus 2x and psi2 of 2y plus x. So that I have written here, and this is particular solution. So in this way we can apply shortcut method. If right hand side is sine of ax plus by or cosine of ax plus by, and here we have to replace d square by negative of a square, that is coefficient of x, d dash square by negative of b square, and d dash is replaced by minus a times b. And remember, here we are replacing d square by negative of square of a square. Some students can misunderstand as it is square of minus a, but it is not like that. We first take the square of coefficient of x and then we take the negative of that squared quantity. Same thing for d dash square. D dash square is replaced by negative of square of coefficient of y, and d dash is replaced by negative of product of these two coefficients of x and y. Another thing is, when we replace this d square by minus a square, d dash square by minus b square, and d dash by minus ab, then if f d dash becomes 0, then we multiply by x and we differentiate f d dash with respect to d partially, considering d dash as constant, and after that we rearrange this part in such a way that we obtain d square and d dash square, so that again we can replace d square by minus a square, d dash square by minus b square, and d dash by minus ab, and again whatever we obtain, that must be non-zero. If in this step also this becomes 0, then we multiply again by power of x and we differentiate again with respect to d. So we will continue that process and we will keep multiplying by powers of x. So this power of x is equal to number of times we are differentiating f d dash with respect to d. Here we have differentiated f d dash with respect to d single time, therefore we have multiplied by x only. Suppose we had differentiated f d dash 2 times, then we would have x square in the product. So that thing we must be clear. So this is all about this session, and I hope you like this. Thanks for watching.